Assalamualaikum warahmatullahi wabarakatuh. Today I will presenting our group article critique slide. Our group have total of 5 members, which are Aqif, Najib, Thaqif, Shawn and Haris. So we move on to first part, which is summary. This article reviews how hybrid energy system, which combine batteries and supercapacitors, can improve electric vehicle performance. By analyzing various technologies, the authors show that a hybrid setup handles sudden power bursts much better than a battery alone. This combination protects the battery from stress, increases its total lifespan, and ultimately makes electric transport more sustainable and environmentally friendly. Secondly, clarity of research question. The research question is very clear and easy to find in the introduction. The authors focus on a specific problem, which is battery damage caused by frequent starts and stops in traffic. They clearly ask how a hybrid system can provide a more durable solution for modern vehicles. This focused approach and logical structure make the entire study very easy for the reader to follow.
Now I would like to present the appropriateness of methods for this article, which we've divided into two main parts, the research design and the methodological gaps. First of all, for the research design, the article adopts a descriptive and qualitative approach to synthesize its complex engineering characteristics. We can see this structured across three main tiers, which are the components, the circuit topologies, and also the EMS algorithms. The evidence for this comes directly from section 1, where the author states that the paper presents a comprehensive review and comparative analysis. This confirms that the article relies on qualitative synthesis of existing secondary data rather than a primary experiment. Next, looking at methodological gaps, the most apparent limitation is the lack of systematic instruments. As shown in the table of contents, there is no dedicated methodology or search strategy section. The authors do not document specific search trees, databases, or personal selection rules, which makes this a narrative review rather than a repeatable systematic study. Additionally, there is an absence of inferential or comparative statistics, as the paper relies purely on qualitative categorization without running statistical cross comparison across days. Now, I would like to present. Now, moving on to the validity of results and data interpretation. First, we found that the article's conclusions are evidence-based. Its core claims are scientifically sound and directly grounded in physical laws related to SQR heat loss reduction. As quoted in the article, super, supercapacitors have a very low internal resistance, allowing them to absorb or deliver high current pulses during sudden acceleration or regenerative braking, thereby protecting the battery from stress and thermal degradation. Secondly, the article provides effective data communication by utilizing clear structured visual frameworks. As shown on the screen in figures 3 and 4, complex hardware topologies and control strategies are neatly translated into accessible diagrams. However, the article also have exhibit data limitation and shortcomings. The cited literature relies heavily on standardized driving profiles under laboratory conditions, while ignore the real-world environmental unpredictability. This is confirmed in section 5, where the authors note that most origin measurement strategies are evaluated using standard driving cycles such as WLTP or UDDS under controlled operating conditions.
Now let's look into the discussion of the limitation of the article. First of all, the article lack of empirical and quantitative proof for battery degradation. The paper claims that everyday driving causes severe permanent battery damage, but the authors provide no concrete data, measurement, or any laboratory covers to support this statement. It treats all lithium-ion batteries behave identically, which means all chemistries of batteries have a same characteristic. which from what we can see that actually the LFP batteries, for example, tolerate power spikes much better than NMC batteries. The study also fails to take into account for modern battery management system (BMS). So what is BMS actually? BMS is specialized computer which use smart software and liquid cooling to shield cells from heat and power surges. Second, qualitative versus quantitative assessment of the supercapacitors. The paper proposes adding a supercapacitor bank to form a hybrid system, but it fails to calculate whether the minor gain in the battery lifespan outweighs the loss of passenger space due to the size and overall driving range due to the extra weight. Supercapacitors require specialized power converters that lost 3% to 8% of energy as heat, and the study offers no proof that energy saved during peak power moments offset these ongoing electronic conversion losses. Third, absence of life cycle analysis (LCA) and economic justification. The paper lacks a concrete model to justify whether spending $1,000 to $3,000 on supercapacitors is a better investment than simply adding 10% more capacity to the main battery pack. The discussion on control methods to make sure that the accumulator, the battery, or the supercapacitors perform efficiently remains purely theoretical, providing no real-world test data to measure reaction speeds or actual energy saving under real driving conditions.
Hello, my name is Muhammad Thaqif and I will continue for significance and relevant findings. For significant and relevant findings, we have a hybrid energy storage system, which is HESS, that combine batteries and supercapacitor to improve EV energy storage performance. And then we move to complementary characteristic, which is the battery have high energy density for suitable long distance driving. And then for supercapacitor, it has a high power density which is suitable for rapid acceleration and regenerative braking. And then we move the reduced battery stress, which is supercapacitor handle sudden high power demand, and then reduce frequency high current, which is that charging and discharging of batteries. And then we move to potential benefits, which is extend the battery lifespan, improve energy efficiencies, enhance EV performance, and support better energy recovery during regenerative braking. And then the last, we move to relevance to EV development. It is address limitation of conventional battery only, and then is important as a demand for efficient and sustainable electric vehicle that continues to grow. And then the key point of the significant and the relevant finding, which is the combining batteries and supercapacitors can provide both high energy capacity and high power performance, which is I will continue for ethical concern. Ethical concern, we have environmental impact, which is the battery production require raw materials such as lithium, cobalt and nickel. To produce this material raw, the mining can cause environmental pollution, habitat destruction, high water consumption, and carbon emission. And then second, we have human rights and labor issues. The mining activities may involve concern about worker safety, fair wages, human rights, and ethical source of raw material. And third, we move to battery and supercapacitor disposal. Increasing EV adoption will lead to more end-of-life energy storage component. Its improper disposal may cause environmental pollution. Recycling is important to recover valuable materials and reduce waste. And last, we go to responsibility for sustainable development. Manufacturers should consider the entire circle life, which is the first one, we have raw material, and then we move to manufacturing, then usage, and then recycling, and the last one, disposal. Technology should not simply shift environmental problem from vehicle emission to mining and waste. And then we have a key point, which is the development of hybrid energy storage system should balance technological progress with environmental sustainability, ethical material source, and social responsibility.
To conclude, this article gives us a really clear picture of how to improve energy storage in electric vehicles. First, lithium-ion batteries are great for storing energy, but sudden power spikes during driving can easily damage them over the time. By adding supercapacitors to handle those high power surges, we can protect the battery and make it last much more longer. Second, the paper compares different designs and shows that semi-active systems are the most practical way for real-world manufacturing. They give the best balance between cost and performance, while energy management systems or EMS make sure the vehicles stay safe and efficient under different driving conditions. Finally, this connects directly to environmental goals, as manufacturing electric vehicles actually creates a lot of pollution at first. So by extending the lifespan of these batteries is the key to offsetting that impact and making EVs truly sustainable in the long run. That's all from us. Thank you.